Hello, am I audible to all of you?
It's kind of echo.
Okay, echo is coming. Like I don't. Okay, so the main idea of this main aim of this session is basically I prepared few questions and I'm planning to solve uh, these questions so that I can cover few concept of week 1 to 4. Okay. Okay, so let me share my screen. Okay, I guess my screen is visible to all of you. Okay, like I just want to make sure whether my screen is visible.
Yes.
Okay, fine. Yeah. Okay, so okay, so fine. So okay, so let's start the session. So if you have some doubt, like while I'm explaining few things, these things, if you have some doubt, then feel free to ask your doubt. Okay, so let's start with the first question. So 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 the first question is basically we just need to know. So we have a relation. So we have defined a relation on this set A. So A consists of 8 elements. So A is basically 1, 2, 3, 4. Okay. So again, like so am I audible?
Yes.
Yes.
Okay. So
Yes, audible.
okay. So someone said like I'm not audible. So that's why. Okay. Okay. So so the first question is, so we have a relation. We have defined one relation on a set on this set A. So A consists of 8 elements. So A consists of 8 elements. So these elements are 1, 2, 3, 4, 5, 6, 7. And we have a relation. So okay, so before that, so let me recall. So relation is nothing. It's a, so if R is a relation, so if R on A, so this relation is nothing but it's a, so basically R is a subset of A cross A. Okay. So relation on a set A is nothing but it's a subset of A times A. So this is basically the Cartesian product of A and A. So we have defined a relation R on this set A. So what is that relation? So relation is, so x comma y such that y is divisible by x. Okay, so the condition is y is divisible. So we are taking such pair x comma y such that y is, this y is divisible by this x. The second component is divisible by the first component. Okay, so we need to check whether that relation, whatever relation we have defined, whether that relation satisfy this property. So whatever property we have mentioned in this options. Okay, so we need to check whether this relation R is reflexive, whether this relation R is symmetry, or whether this relation R is transitive, or whether this relation R is an equivalence relation. So equivalence relation is nothing but if a relation is reflexive, symmetry, and transitive, then we call that relation to be an equivalence relation. Okay, so let me so to check whether this relation R is reflexive or not, the first task is I need to write down all the elements of R. Okay, so the first task is, so I have defined using some kind of statement, right? So so I have defined using some statement. So this is a statement. So using the statement, I have to write down explicitly all the elements of R. Okay, so so can you tell me what are the elements? Can one of you tell me what are the elements of R? Like how we should proceed to complete?
Yes,
Yes.
sure. So we'll start with 1.
2,4.
One.
Okay, so just let the first person to
So 1 to 1, 8, all the elements.
yes.
Then you have 2, 4, 2, 6, 2, 8. Then you have 3, 6.
Yes, 3,
And you have
6,
4, 8. 4, 8.
4, 8, correct. So
Yeah.
so let suppose the first, so let me start. Suppose the first element of this pair is 1. Okay, see, if the first pair is 1, then I have to take the second pair in such a way that the first pair divides the second pair. That is the condition, right? Y is divisible by X. Okay, so I have to take the second pair in such a way that the first pair divides the second pair. Since my first pair is 1, so 1 divides all the other elements of this set, right? This set 1 to 8. Okay, so 1 divides all the other elements of this set. So I can take the second pair, I can take to be 1. Okay, sorry, let's start with 1. So I can take this to be 1. Then I can take 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, comma 6, 1 comma 7, and 1 comma 8, right? So if the first pair is 1, these are the possible elements that I can make out of 1. Okay, so the second thing is, if the first pair is 2, okay, if the first pair is 2, then what are the possible choices for the second pair, right? If the first pair is 2, what are the possible? Then similarly I have to take the second pair in such a way that the first pair divides the second pair. So as you can see, certainly I cannot take 1, right? I cannot take 1 here because 2 doesn't divide 1. Okay, so I cannot take 1 here, so I have to start with 2, right? So so I can write here 2, then 2 comma, so I cannot take 3 here, so then I can take, but I can take 4 because 2 divides 4. Then I have to take 6 and 2 comma 8. So these are all the possible pair that start with 2. Okay, so the next thing is I have to start with 3. So again, I cannot take 1, 2 because 3 doesn't divide 1 and 2. So I have to start with 3. Then the next choice is 3 comma 6, right? So what about so again next thing is I have to start with 4, right? If I start with 4, then what I can take 4 because 4 doesn't divide 1, 2 and 3. So I'm left with 4, and certainly 4 doesn't divide 5, 6 and 7. So I can take 4 comma 8. So the next thing is I have to start with 5, right? So once I start with 5, I cannot take 6, 7, 8, 1, 2, 3, 4, right? Because 5 doesn't divide all these numbers. Okay, so I have only one option here, 5 and 5, right? And similarly for 6 also I cannot take any other number apart from 6, right? And for 7 I cannot take any other number apart from 7, right? And for 8 also I cannot take any number apart from 8. Okay, so this is my set, right? This is the relation that basically, so this is the relation that we have defined on the set A, right? So this is the relation. We have explicitly wrote down all the elements of this relation. So the first thing we need to check, so as you can see, the first option says whether this relation R is reflexive or not. So any idea whether this relation R is reflexive or not?
It's
Yes, it
reflexive
is.
because both the elements belong to set A.
Okay, so for the reflexive, what you need to check? You need to check for all A in A. So for the reflexive relation, what we need to check? We need to check for all, if for all A in A implies A comma A is in A comma A is in R, then I can say that my relation is reflexive. Okay, so now I have to pick all the elements of A and one by one, and I have to check whether A comma A is in R or not. Okay, so if I pick the first element 1, so as I can see 1 comma 1 is in this relation. Okay, so 1 comma 1 is in R. Okay, and similarly if I pick the second element 2, then I can easily see that 2 comma 2 is also in R. So that's why so the condition holds for 2, but I have to keep going because I have to check all the elements of A. So the next thing is I have to go for 3, and similarly I can see that 3 comma 3 is also in R, and similarly as you can see 4 comma 4, 5 comma 5, 6 comma 6, 7 comma 7, and 8 comma 8 all are in R. So this condition holds for this relation. So this condition holds for this relation. So that means I can say that whatever relation I have defined, R is reflexive. Okay, correct. So the first that means the first condition is true, right? So the next option is I need to check whether this reflection is symmetry or not. Okay, so this is the next thing I need to check whether this relation is reflexive symmetry or not. So for symmetry, what I need to check?
The ordered pair of a set and the reverse order pair should be same, like 1, 2,
Should
2, 1.
be following the condition of divisibility.
Yes. So in generally, so as you can see, like it's more or less clear that divisibility is not a symmetry condition. That means if y is divisible by x, that doesn't imply that x is divisible by y. So hopefully we can guess that most likely this relation is not symmetry, but we have to give a specific example where this condition doesn't hold. Okay, so for the symmetric thing, okay, so what is the condition for symmetry?
If x and y follow certain, if y is divisible by x, x should also be divisible by y.
Yeah, that is basically you are saying using this and that is correct. So you are using basically using this statement, but I'm asking the mathematical way of saying the
Representing.
so
If x and y belongs to R, then y and x should also belongs to R. Wherein
correct,
if
correct. So for all a comma b in R, this should imply that B comma A also in R. So this condition should hold all the pairs of R. Okay, not for a single pair. It should hold for all the pairs of R. So again, I have to go and check whether this condition holds for all the pairs of R or not. So as you can see, for the first pair, so if I write this first pair like A comma B, then I need to check whether B comma A is in R or not. Okay, so if I flip A comma B, then so if I flip 1 comma 1, then certainly I am going to get 1 comma 1. Okay, and 1 comma 1 is in R. So if I flip 1 comma 1, then I'll get the same thing, right? Because here A and B are same. Okay, so that means this condition holds for 1 comma 1. Okay. Okay, so the next thing is I have to go and check for the next element 1 comma 2. So this is my A comma B. If I flip A comma B, then I'll get so here A comma B is 1 comma 2. So if I flip A comma B, then I'll get B comma A, right? So here B comma A is what?
2, 1.
2, 1. But 1, so as you can see, 2 comma 1 is not a member of R because 2 doesn't divide 1, correct? So that means this condition, the symmetry condition, does so I can give you at least one element of R where this condition doesn't hold. But to say that this relation is symmetry, I have to make sure that this condition holds for all the elements of R. But I have one element where this for that element this condition doesn't hold. That means this relation R is not symmetry. Is it clear like why this condition is this relation is not symmetry? Okay, fine. So yes, Susil Divedi, you have some doubt? Okay. Okay, so let's go and check the other condition, whether this relation is symmetry, transitive or not.
Yes, it's transitive.
Yeah. So the next thing is, so the next condition is whether this condition, whether whatever relation we have, whether that relation is transitive or not. So what is the condition? What is the condition for transitive?
So it says that if x comma y belongs to R and y comma z belongs to R, then x comma z should belong to R.
Correct. So it basically is, so the condition for transitive is for all A comma B and B comma C in R, it should imply that A comma C is in R. So if the condition holds for all such pairs, all such possible pairs, then I can say that my relation R is transitive. So again, it's since as you can see this number of elements is it's huge in some sense, so slightly difficult for you to check all the possible pairs. Okay, so let's try one by one. So so basically what we need to do, we need to find all the pairs which are of this form, right? Which are of this form, that is A comma B. So we need to find all possible so we need to find two pairs which are of this form, A comma B and B comma C. That is the second element of this pair, is same as the first element of the second pair. Okay. So, so let's take the, so suppose this is my first element 1 comma 1. So then if I take my second element to be 1 comma 2, so this is my A comma B and the second element is my B comma C, right? So, so then what I need to check? I need to check whether A comma C is in R or not. So what is A comma C now? A comma C is 1 comma 2, right? So you can easily say that 1 comma 2 is in R. Okay. So the next thing is, similarly you can check 1 comma 1 and 1 comma 3. Okay. So again you can say that 1 comma 3 is in R. So it's slightly difficult for you to check like this. So it's better now to use the definition, the way we have defined A comma B, right? So now it's useful for you to use this definition. Okay, instead of going like this, checking one by one, it's always better for you to go with the definition. Okay, so what I need to do, so the first condition says A comma B is in R. That means B is A divides B, right? So if A comma B is in R, that means A divides B. Okay, this is what I can write from this condition. Okay, so the second thing is B comma C is in R. So that means B divides C, right? So A divides B and B divides C. So using these two things, I can say that A also divide C, right? So if A divides C, that means by this condition, so by the definition of our relation, so that means B is divisible by, sorry, C is divisible by A. So that means I can write A comma C is in R. Okay, so basically I have proved it for a general case. Okay, instead of checking one by one, I proved it generally. So that means my relation R is transitive. Okay. Is it clear how we check that R is transitive?
Yes.
Okay, fine. Okay, so yeah, so the next option is, so the third option is correct. Second option is certainly incorrect. R is not symmetry. Third option is correct. And what about the last option?
It's not equivalent
Because for so for equivalence relation, I want the relation to be reflexive, symmetry, and as well as transitive. But in this case, so as I can see, my relation is not symmetry. So that's why I can say that my so R is not a equivalence relation. Okay. Okay. So the next question is, I have a map. Okay. So I have a map. So I have defined my map like this. If the input, so it's a map from set of all natural number to set of all natural number. So here, as you can see, the domain. So this is my domain. And this one is my codomain, right? So I have defined my map like this. If the input is a odd number, okay. So if the input is odd, then the output is basically n plus 1 by 2. Okay. And the input is even, my output is n by 2. Okay, so as you can check, this is a well-defined map, right? This is a well-defined map. Okay, so can one of you tell me whether this map, so basically so the main aim of mine is to check whether this map is 1 1 and onto. Okay, so I need to check two conditions, whether the first one is whether this map is 1 1, the second one is whether this map is onto. So any idea how to check whether this map is 1 1 or not?
Yeah, we can start. What we can do is we can just start listing out the numbers from 0 onwards. Yeah.
Okay. Okay, so so as you can see, what is the output for so what is f of not 0? So basically so n starts with 1 1 2 3 4 5. Okay, so let me tell you, so the set of natural number start with 1 2 3 4 5 and so on. Okay, so we are excluding.
But you see, actually, natural number starts with 1 because I was just watching some of the lectures. So according to Professor Madhav Mukund's lecture, n starts from 0. That's why I said 0.
So whole number starts from 0.
Okay,
Okay,
but okay, so
okay,
yeah, okay.
sorry. No. So the thing is, okay, so so the problem is, okay, so the problem is in the case of calculus part. So there actually we take n from 1 onwards. Okay, so but in case of this week 1 to maybe 6 or 7, so 6 maybe. So here n start with 0. You are correct.
Okay.
Yeah. So okay, so one can easily see that here. So from the expression, so so what is the image of f of 0? It's
0.
It's 0, correct, because 0 is even and image is basically 0 by 2, which is 0. Okay, so next thing is, what is f of 1? F of 1
is coming to 1 on 1 plus 1 by 2.
correct. So since 1 is odd, I have to consider this one, this definition. So 1 plus 1 by 2, which is 1. Okay. So the next thing is f of 2, which is 2 by 2, 1, right? So now using these two information, I can say that my map is not 1 1, right? Because f of 1 is same as f of 2, right? But certainly 1 is not equal to 2. So I have two distinct element, and basically both of them map to the same element. Okay, so that means f is not 1 1. Is it clear, like why this function is not 1 1? Because we can actually write down two elements, and image of both the elements are same, right? Okay, so we can say that this map is not 1. So the next thing what we need to do, we need to check whether this map is onto or not. Okay, so for ontoness, what we need to check?
For onto, we need to check that the codomain is the same as the domain.
No. For ontoness, we don't.
For onto, we have to check if the range is equal to L.
Sorry, range is equal to codomain.
Yeah,
sorry.
yeah, correct. So we need to check whether this range is same as the codomain. So basically, we need to check whether n. So basically, we need to, so more or less we need to check whether n is the range of f or not. Okay, so so to show that to show that whether n is a range or not. So what basically I need to do? I need to show that to prove that n is n is the range of this function. What I need to do? I need to if I pick any element from n, and if I can show that there is a x in the domain. So in this case, domain is also n. If I can show that there is a x in the domain such that f of x is equals to a, then I can conclude that my range is n, because what basically I'm showing. So I'm showing for each element in the codomain, I have a pre-image. So for each element in the codomain, I have a pre-image in the domain, right? So so now we need to use this trick. Okay, so suppose you pick a element a. Suppose you pick a element a in your codomain. So either a is even or a is odd. Okay, either a is even or a is odd, right? So okay, so it doesn't matter actually. So if a is even or odd, so okay, so let me, because this second definition, so using actually the second definition, you can directly say that this function is onto. We don't have to consider these two different cases. So you pick any element a which is in the codomain, right? Now what you do, you take x to be 2a, right? You take x to be 2a which is in your domain, right? Since x is 2a, 2 times some number, that means x is even, right? So now what is f of x? What is f of x by the definition?
A.
Right? So basically x is even. So by the definition it says if my number is even, then the image of that number is n by 2. So then f of x is basically x by 2, which is 2a by a, right? So what basically I did, so what basically I showed, if I pick any number in the codomain, okay, if I pick any number from the codomain, I have a element in the domain which is x equal to 2a, such that image of that element is a. Okay, so f takes this x to this a. That means range of f is n. Okay, so that means f is onto. So is it clear how we showed that this function is onto?
Yes.
Okay, fine. Yeah. Okay, so then from here we can say that f is onto. So the third option is correct. So f is onto, but f is not 1. Okay, so let's go to the next question. So here what we need to do, we need to compute so you have a line, and some bunch of data are given. So you need to find the sum square error for this line using this given data, right? So what is the procedure to compute the sum square error? Can someone tell me briefly how one should compute the sum square error?
Yeah, so the thing is that these are the actual values. So you can get the predicted values from the equation. And then you subtract the y predicted from the y actual and square it and add it.
Correct. So this is how one should compute the SSE. Okay, so so the given function is y. So as you can see, f of x is nothing but y, which is x plus 1. Okay, so what we need to do, we need to first compute. So some bunch of data are given. So what we need to do, we need to compute yi and f of xi. So you can be basically, you can write this as yi xi. So this is x1, this is y1, this is x2, this is y2, this is x3, y3. So we have okay, so we have 5 points. Okay, so what we need to compute here, yi minus f of xi whole square. Okay, so what is y1? y1 is 1. And what is f of x1? F of x1 is basically 2, right? And similarly, what is y2? So this is basically actual data, and we are actually using this function to compute f of xi. Okay, so the next thing is y2 is 1 and f of x2. So if I compute f of x2, what is f of x2? 2. So f of x2 is nothing but x2 plus 1. Okay, so this is 3, right? And similarly, so x3 is, sorry, y3 is 2 and f of x3 is, I guess, 4, right? And okay, so next thing is y4, which is 5, and f of x4 is also 5, right? Because x4 is 4, so 4 plus 1 is 5. And similarly, y5 is 7 and 7, and f of x5 is also 7, right? So now we have computed f of xy. So the next task is we need to find yi, the difference of yi and f of xy, and we have to take the square. Okay, so this is nothing but 2 minus 1 square, which is 2 minus 1 square. It doesn't matter how you take yi minus f of I whole square or f of xi minus yi whole square, because since you are taking the square, eventually you will get the same thing. Okay, so this square is 1, and similarly 3 minus 1 square, which is 4. Okay, and again this is also 4 minus 2 whole square. Okay, so the next thing is 5 minus 5, which is 0. 5 minus 5 is 0, and if you take the square, also you'll get the 0. Okay, so since we have now computed yi minus f of I whole square, so to find the SSE, what you need to do, so we have 5 points, right? So we need to add this yi minus xi, yi minus f of xi whole square for all these values, that is y1 to 5, right? So we need to add all these things, and if we add, then basically we'll get 4 plus 4, 8, which is 9. So for this given data, so for this given function and the given data, the SSE is 9. Okay, So the sum square error for this function with respect to this given data is precisely 9. Okay. So this is a probably the easier one, this function. So similarly, the same procedure applies to each and every function, and you can do it accordingly. Okay. Okay. So the next thing is, so the next question is about the quadratic function. Okay. So this is my function. So this is a this is basically, it's a degree 2 polynomial, right? It's x square minus 8x plus 15, right? So what you need to do, we need to find, we need to basically find the solution of all these questions. Okay. So the first option says, what are the x-intercept and y-intercept? So can one of you tell me what do we mean by x-intercept and y-intercept?
So the x-intercept is where the y is equal to 0.
Correct.
And the y-intercept is where the x is equal to 0.
Correct. So the x-intercept, so you have a function, and if you draw the graph, right? If you draw the graph as a quadratic function, maybe so let's say this is the graph, okay, for a quadratic function. So x-intercept is basically the points where the graph touches this x-axis. So this touches x-axis means the y coordinate is 0, right? That means y coordinate is 0 means basically p of x is 0, because this point is basically what? If you pick any arbitrary point, the point is what? X comma p of x, right? So the y coordinate is 0 means p of x is 0. And what is y intercept? Y intercept is basically where the graph touches the y axis. Okay, so this is here y axis. So y axis, if the graph touches the y axis, then the x coordinate at that point is 0. So the coordinate of this point is precisely, so the x, if the x coordinate is 0, then the y coordinate is p of 0, right? So what we need to do to find the y intercept, what we need to do, we need to find this point 0 comma p of 0. So the y intercept, so the y intercept is 0 comma p of 0. So what is p of 0 here? What is p of 0 here?
15.
Correct. Okay, so one suggestion, so I guess only one person is answering the question. It will be better if few of you answer the question and participate in the session. Okay. So the y-intercept is basically p of 0, which is 15. Okay, so this is 0 comma 15. Okay, so this is my y-intercept. And what about the x-intercept? How I should proceed to find the x-intercepts?
So you
You
put
can
p of
apply
x as 0.
15.
Okay, yeah, so Lakshmi, yeah, please continue.
You can apply the value of 15 in the equation, right?
No, why?
Okay.
If I apply the value of 15, so how one should find the x-intercept? So x-intercept is basically the points where the y coordinate is.
Roots of the equation.
Correct. So
Factors. Yeah.
correct. So
Factors
x-intercept
of
is
x.
basically the points at which p of x is 0, right? That means the points at which x square minus 8x plus 15 is 0, right? So So can one of you tell me what are the factors of this polynomial?
5, 3.
5
Four,
or
3.
3?
Yeah.
Yes. So this is nothing but x minus 3 into x minus 5 equal to 0. That means x equal to 3 or x equal to 5. So that means my x intercepts are 3, 0 and 5, 0, right? So this is my so this is a x-intercept and this is another. Okay. So the next thing is find the vertex and axis of symmetry of this quadratic function. So what is the vertex of this quadratic function?
First, it would be better to find the axis of symmetry.
Correct.
Since we
Yeah,
know the intercept.
yes, it's always better to first to find the axis of symmetry. Yeah. So what is the axis of symmetry?
So it is a point
Minus,
yeah, sorry. Go ahead.
it is minus of minus 8 by 2 into 1. Yeah.
Yeah,
So it is 4.
So it's better, suppose I have a polynomial like this, ax square, maybe some quadratic polynomial, bx plus c. So what is the axis of symmetry of this polynomial?
Minus b by 2a.
Minus b by 2a.
So it's better to say not minus b by 2a, x equal to minus b by 2a. Okay, so the axis, it's axis means what? It's a line, right? So it's better to tell x equal to minus b by 2. Okay, so this is my axis of symmetry, right? So so if I apply this formula to this polynomial, okay, if I apply this formula to this particular polynomial, x square minus 8x plus 15, okay, so if I compare, then what I will get? Minus b, which is minus of minus 8, okay, which is minus of minus 8, which is 8, okay, this is plus 8 by 2a. So here, as you can see, the coefficient of x square is 1, and if I multiply with 2, then I'll get 2, so which is 4. So x equal to 4 is the axis of symmetry, right? So x equal to 4 is the axis of symmetry for this quadratic function. Okay, then what about the vertex?
-1.
Sorry,
Minus 5. 4 comma minus 5.
4 comma, correct. So the vertex is, so the coordinate of the vertex is minus b by 2a and f of minus b by 2. And as you can see, we have already computed minus b by 2a, which is 4, right? Which is 4. And the only extra thing we need to do is basically to find f of 4. And f of 4 is, I guess, 16. So it's 16 minus 32 plus 15, right? So I guess it's minus 1, right?
Yes.
Yeah. So okay, so this is the vertex of this quadratic function. Okay, so now I guess now we have enough information to draw this quadratic function, right? We know the x-intercept, we know the axis of symmetry, and as well as we know the vertex. So this, whether this quadratic function is open downwards or open upwards?
Upwards.
Words.
Outward.
Because the coefficient of x square is positive, right?
Yes.
Yes. So since the coefficient of x square is positive, this quadratic function is open down. So now we can easily draw the quadratic function. So if we try to draw this quadratic function, so so the roots are 3 and 5. So let's say this is 3, this is 5, and and the quadratic function is open downward. So this is the axis of symmetry 4. Not axis of symmetry, this line x equal to 4 is axis of symmetry. So if I draw, should look like this, and probably should cross the y-axis somewhere here. Okay, so 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 this point is basically your y-intercept. So y-intercept is 0, 15, right? So this point is 0, 15, okay, and this point is 3, 0, and this one is 5, 0, and this point, so the axis of symmetry touches the graph of the function at the vertex, which is 4, -1, right? So this is so the graph of this function is similar to the graph that we have drawn here. Okay, so so this is the graph of this quadratic function. Okay, so as you can see, this parabola, so since you know this parabola is symmetry about the axis of symmetry, so that is why the name of the axis symmetry is so the way we have named it, it's basically the parabola is symmetry about that line. Okay, so the next thing is what is the maximum or minimum value if it exists. So what is the maximum and minimum value of the parabola? So whether this parabola has a minimum value?
Yes.
Yes.
So the next question is whether the parabola has a maximum value?
No, it's
The vertex.
infinite.
Correct. Since it's bounded below, right? It's bounded below. So that's why, since it's bounded below, that means the y value cannot go below of this line, right? The y value cannot go below of this line. Okay, that means the parabola has a minimum value. Okay, but as you can see, there is no bound for the graph of the function in the positive y-axis. Okay, that means this function is not bounded above, but the function is bounded below. That's why this function has a minimum value, but this function don't have maximum value. And the minimum value of the function is what?
The vertex, 4,
Minus-
-1.
The y coordinate of the vertex. Okay, so not 4, -1, the y coordinate.
Yes,
Y
yes.
coordinate of the vertex. Okay, so the
Yes.
minimum value of this polynomial is p of x is -1. Okay, so this is how we have computed the minimum value of the polynomial. So the next question is, what is the range of this polynomial? Any idea how we can compute?
Yeah, greater than
Yeah.
-1.
-1 to infinity, with a closed bound at -1 and an open bracket in infinity.
Correct. So as you know, this parabola is bounded below, right? There is so the parabola cannot take any value which is less than -1, right? And parabola can take any value which is greater than -1. Okay. So parabola cannot take any value which is less than -1. This quadratic function, or you can say parabola. So the parabola cannot take any value which is less than -1, because the minimum value of p of x is -1, and the parabola is bounded above. That means the parabola can take any value which is greater than -1, right? So p of x is always greater than equal to -1. Okay, and this parabola takes -1 at this point, at at the vertex, that is 4, at x equal to 4, the value of the function is -1. Okay, so the parabola is always greater than equal to -1. That means the range of this polynomial is -1 to infinity. Okay, and similarly, if you have a parabola which opens downward, so for that parabola, you can instead of finding this minimum value, you can find the maximum value, and similarly you can find the range of that parabola. Okay. Okay, so the next thing is okay, so I guess we have computed the range of the parabola, and so the next thing is what is the slope of this parabola at this point 3 comma y. Okay, so this is my parabola p of x, which is x square minus 8x plus 15. So I need to find the slope of this parabola at this point 3x 3 comma y, right? Yeah, correct, 3 comma 1. So what is the formula for the slope of a quadratic function? If my quadratic function is x square plus bx plus c, what is the slope? Any idea?
So you differentiate it by x and then equate it to 0?
Yes, correct. Not yet. So you just need to differentiate.
It's minus b by 2a.
Yeah. So no. So you are saying that. So you are saying basically when you are equating this to be 0, you are basically finding the point at which the slope is 0. Okay. So when you are equating.
Okay.
Okay.
Correct.
So the slope is basically what? If you differentiate, okay, so you are using the word differentiation. So if you differentiate, is what you will get? You will get 2ax plus b, right? Okay, so at point x comma f of x, right? At point x comma f of x, the slope of the parabola is precisely 2ax plus b. So as you know the slope, so if you have a quadratic function like this, so the slope is basically will give you the slope of this tangent line at that point. Okay. With this 2ax plus b is nothing but the slope of this line. Okay, so for this case, what we are trying to find out the slope of this polynomial at point 3 comma y. So y is nothing but what? Y is nothing but p of 3. So which is 9 minus 24 plus 15, right? So it's 0. So we are trying to find the slope of the parabola at this point. Okay, and the slope of the parabola is what? 2x plus p. So here x coordinate is 3. So we just need to replace. Okay, in place of x, we just need to replace 3, right? So for this given parabola, so which is x square minus 8x plus 15. So here 2x plus p is what? 2x minus 8. Okay, so once we substitute x equal to 3 here, what we will get? Minus 2. Okay, so this is the slope of the parabola at point 3 comma 0. Okay, okay, so I guess we have computed the slope of the parabola. Okay, so so the next thing, probably the last thing what I'm going to discuss, So if you have a polynomial, like if you have a polynomial, how we can compute the number of turning points of the below polynomial? Okay. So can one of you, like, maybe you can take maybe 2-3 minutes to solve this question number 1, and after that you can give me the answer, like what so for this polynomial, given polynomial option 1, you need to find the number of turning points, and certainly you have to share your idea, like how you have computed the turning points of this polynomial. You can take maybe 2-3 minutes.
It's 8.
Sorry?
8.
Yeah, I'll come to that. I don't know the answer.
Oh.
Once I compute, then only I can tell you.
It's 5.
Okay, so someone said 5 and someone said 8.
Yeah.
Okay, wait. I think I'm wrong. Just a minute.
Okay, so if not a problem, you can change your answer later.
So 9.
9. Okay, so one more answer which is not in the list, that is 9.
So 7. The correct answer is 7.
Okay, 7. Okay, I'll write it down. Okay, so one more answer which is okay, so I guess you have said 5. So okay, I'll remove this one, and instead of 5 it's 7. Okay, any more possible answer? Okay, so okay, so tell me how, like, okay, let's maybe say 7. Someone said 7. Can you tell me how you got
Yeah.
7?
Yes. So what I will do is first we find out all the roots of the equation.
Yeah.
All right. So for the roots of the equation are -4, -3, -1, 4, 5, and 6. Okay. So now the thing is, wherever and you check for the multiplicity of the zeros.
So the main idea you are so basically what you were trying to draw the graph of the polynomial, right?
Yes.
Correct. Yeah. So once you draw the graph, then by just looking at the graph, we can find out the turning points. Okay. So the main idea, yeah. So your idea is perfectly fine. So the main idea, idea to solve this question, we need to plot the polynomial. Okay. So to plot a polynomial, you need maybe 2-3 things. So the first thing is you need to find the roots. Okay, so you need to find the roots, and so once you know the roots, basically you know the x-intercept. Okay, so finding the roots and finding the x-intercept, they are basically same. So the next thing is okay, so you can draw without knowing the Y intercept, but it's always better to find out the Y intercept also. So the next thing you need to find the Y intercept. Okay, and the last thing is, which is quite crucial, is the end behavior. Because for this polynomial, actually it's really easy. So see the polynomial of this form, it's really easy for you to find the roots. Okay. So the main last crucial thing is the end behavior. Okay, so so by just looking at the polynomial, we can find out the roots. Okay, so the roots are 1, sorry, -1. So x plus 1 whole square, so -1. And at the same time, while computing the roots, we have to also note down the multiplicity of the roots. Okay, whether, so certainly I'll later I'll let you know why we need to compute the multiplicity also. Okay, so so what is the multiplicity of -1 here? What is the multiplicity of -1?
2.
2. Okay, correct. So the multiplicity is for -1, the multiplicity is 2. Okay, and the next one is 2. Okay, so the next root is 2, and for 2 the multiplicity is 1, because it's basically x minus 2. Okay. So the multiplicity is 1. Okay, so the next root is 3, and the multiplicity of 3 is 2. Okay, multiplicity of 3 is 2, and the next one is -4, and the multiplicity of -4 is 1. Multiplicity of, yeah, correct, -4 is 1, and the next one is 5, x minus 5, which is basically 5, and the multiplicity of 5 is 1. And the last root is 6. Okay, and the multiplicity of 6 is 1, right? Sorry, 2. And what is the Y intercept of this polynomial? Probably it's huge. Okay, so Y intercept is P of 0. It's, I guess it's 1 times -2 times 3 square times 4 times 5 times -6 square. Okay, so okay, this is a number, let's say a. Okay, so the Y, you can use calculator to find out the Y. You can multiply using calculator. Let's say this number is a. Okay, so okay, so the thing is, to find the end behavior, it's always better to write the polynomial function in a particular form. So as you can see, so it's always better. For example, if you see the polynomial here, we have written 5 minus x. So instead of writing 5 minus x, it's always to write, so instead of writing a minus x, it's always better if you can convert this a minus x into x minus a whole minus. Okay, so because they are the same thing, right? So now what we will do, instead of writing this polynomial as x plus 1 whole square, x minus 2, x plus 3 whole square, x minus 4, and 5 minus x, we'll simply, so instead of writing 5 minus x, I will write minus of x minus 5. So if I write 5 minus x as minus of x minus 5, then my polynomial will become minus of x plus 1 whole square, x minus 2, x plus 3 whole square, x plus 4, 5. Okay, so I don't want to write this as 5 minus x. That's why I'll write this as x minus 5. See, as you can see, since I'm writing instead of 5 minus x, I'm writing x minus 5. That's why I have a minus sign here. Okay. And the last one is x minus 6 whole square. Okay. So this is now this my polynomial is more or less in a standard form. Okay. So now using this polynomial, I'll try to find out the end behavior. Okay. So basically to find the end behavior, what we need to do, we need to find if x tends to plus infinity, what will be the behavior of p of x? Okay. If x tends to plus infinity, what will be the behavior of p of x? Any idea how one should find out the behavior of p of x as x tends to infinity, plus infinity?
Minus infinity.
Yeah. So it'll tend to because the leading coefficient of the x term is negative because you have a negative sign.
Yes. So okay. So no. Okay. Yeah. Correct. So the leading term of p of x is what? So the leading term of p of x is what? So from here I'll get x square. From here I will get x. From here I will get x square. From here I will get x, and from here I guess x, and from here I'll get x square. So 2, 3, 5, 6, 7, I guess 9, right? So it's
Minus
this is
x raised to 9.
yeah, minus x raised to 9. So if x tends to plus infinity, as you can see, so the leading term, so this is the leading term. This leading term tends to minus infinity, right? Because it's minus of x to the power 9. Okay, so I have a minus sign behind x to the power 9. So if x tends to plus infinity, then minus of x power 9 will go towards minus infinity. Okay. So as you know, the behavior of the polynomial is completely dominated by this this leading term. Okay. Since the leading terms is going towards minus infinity, that means the polynomial itself will go towards minus infinity. Okay. Okay. So that means the polynomial will go towards minus infinity. Okay. So now we have computed the at least the positive end behavior, positive direction end behavior, that is x is going towards plus infinity, and that is enough for us to draw the graph of the polynomial. Okay, we don't have to consider the negative direction. Okay, so one direction is enough for us to draw the graph. Okay, okay, so okay, let's draw the graph. Okay, so first thing is we have to see the roots. So 2, so the positive roots are 2, 3, 5, 6. Okay, so 2, let's say 3, and I have 5 and 6, right? And the negative roots are minus 1, minus 4. Okay, so this is minus 1 and this is minus 4. Okay, these are the roots. Certainly, if I draw the graph, then certainly the graph will cross these points. Okay, because since these are the roots of the polynomial, if I'll draw the graph of that particular polynomial, then it has to cross these points, right? So the next thing is the end behavior. Okay, so as you can see, if I'll go towards this direction, right? I'll go towards this direction, that is plus infinity. X tends to plus infinity. Okay, we have already computed that P of X will go towards minus infinity. Okay, that means if I draw the graph, then the graph should come from the below of x-axis, right? Then the graph should come from the below of x-axis, right? From the below of x-axis, right? Because as x tends to infinity, the value of the polynomial is value of the polynomial will go towards minus infinity. So it has to come from the below of x-axis. So from this direction it will come, and will come to 6. But I don't know what will happen once it reaches 6. I don't know whether it will cross or whether it will bounce back towards the same direction, whether it will cross 6 or whether it will bounce back towards the same direction. I don't know what will happen after that, whether it will go like this or whether it will come like this. Okay, that I don't know. And for that, what I have to check? I have to check the multiplicity of 6. Okay, once I check the multiplicity of 6, then it will give me the information. So what I'll do now, I'll go and check the multiplicity of 6. So as you can see, the multiplicity of 6 is 2, right? 2. So it's a even number. Okay, so 2 is even. So if the multiplicity is even, okay, it will bounce back. Okay, if the multiplicity is even, then the graph will bounce back instead of, so it will not cross the x-axis. So instead of crossing the x-axis, it will bounce back. Okay, so it will come like this. So it will come like this. And again it has to go towards 5, and once I reach 5, then I don't know whether it will cross that 5 or it will bounce back. So again, for that I have to go and check the multiplicity of 5. So multiplicity of 5 is what? Multiplicity of 5 is 1, which is odd. Since the multiplicity of 5 is odd, then that means the graph will cross that point. Okay, so it will cross the x-axis. So instead of coming back, it will cross the x-axis. Okay, so it will cross the x-axis, and again it will come towards 3. So again I have to go and check the multiplicity of 3, and multiplicity of 3 is 2, which is even. That means it will again bounce back. That means again it will bounce back. So it will come like this, and it will bounce back, and again it will come back to 2, right? So multiplicity of 2 is 1, which is odd. That means it will cross the x-axis, cross the x-axis, and somewhere it will cut the y-axis, and this precise point is the y-intercept. Okay, and again you can compute the y-intercept, which is 0, a, and again once it crosses the y-intercept, it will go towards, let's say, minus 1, and again we have to do the same thing. We have to check the multiplicity of minus 1, and as you can see, the multiplicity of minus 1 is 2, which is even. That means it will not cross the x-axis, it will bounce back. So will go like this, and again it will bounce back, and once it bounce back, it will go towards -4. And the multiplicity of -4 is 1, which is a odd number. That means it will cross the x-axis, right? So the rough diagram of this polynomial is this one, okay, that we have drawn here. So this is the rough diagram of this polynomial. So this graph, certainly this is not an accurate graph, but this graph is enough for us to compute the turning points. Okay, so as you can see, this is a turning point. This is another turning point. This one is another turning point. This is a turning point. This is also a turning point, and this one is also a turning point. This one is also a turning point. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 turning points. Okay.
So Bashish, there's at x equal to 3 also there's a turning point.
Okay, sorry, I missed this one.
But there are 8.
Yes, correct. So this is the 8. Okay, so we have 8 turning points. Okay, so I guess the correct answer is 8. Okay, so the number of turning points for option 1 is 8. So what about option 2? Now you have the idea. So can one of you tell me what will be the answer for option 2? For option 2?
See, I think this is a 11th degree equation. So the leading term is -2x raised to 11.
Yes.
So as x tends to infinity, f of x tends to -infinity.
So the leading term is -2 power x to
X raised to 11.
11. Yes.
So as x tends to infinity, f of x tends to -infinity.
Correct. Yes.
And then we have to go by the roots. So the roots are -7, -4, -3, -1, 2, 5,
just a
and
minute.
6.
Just a minute. So the roots are -7, -2,
-4.
Okay, -4,
-3, -1.
-3, -1.
2, 5, and 6.
2, 5,
and 6.
6. Okay. So what is the multiplicity of please.
Sir, in question 1, we have x plus 3 whole square. That gives us x equal to -3 as a root, not +3 as a root.
Okay, so maybe I made mistake.
So not sir, in that question only, the first.
Yeah, I got it. Yeah. So then I guess I made a mistake. So what I have -3 here, right? Correct?
Yes, sir.
So this is the only change I guess I have to make, -3. Okay, fine. So then I guess let me redraw this graph. Okay, so let me draw this graph quickly. So the roots are positive roots are 2, 5, 6, right? 2, 5, 6. Yes. 2, 5, 6. The negative roots are -1, -3, -4. -1, -3, -4. again the same argument, it will come from this direction. And what is the multiplicity of 6? It is 2. Will come like this and it will bounce back. Again it will come to 5, and 5, the multiplicity is 1, will cross and will come to 2. The multiplicity of 2 is 1, right? So it will cross and it will cross the y-intercept, will go to -1, and the multiplicity of -1 is 2. So it will come like this and come to -3, and I guess the multiplicity of -3 is 2. Again it will bounce back, and multiplicity of -4 is even, it will cross the x-axis, right? Multiplicity of -4 is even, yeah. So now the number of turning points 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again we are getting the same answer. So the multiplicity is the number of turning points is 8. Okay, so let's go back to the second question. So the multiplicity of 7 is what? So now I'm solving the second option. Okay, so the multiplicity of 7 is what? It's where is 7? Okay, -7. Sorry, it's 2. Okay, and multiplicity of -4 is it's 1. Multiplicity of -4 is 1. Then the multiplicity of -3 is also 1. Multiplicity of -1 is 2. Multiplicity of 2 is 1. Multiplicity of 5 is 2. And multiplicity of 6 is 2. So okay, so before solving this question, so any of you solved this option 2 in between? And
Yes,
yeah, so what is the answer?
9 turning points.
Okay, so 9, someone said 9, I guess someone said 10, also 8. Okay, so okay, let's draw the graph. Once we draw the graph, then everything will become clear.
Sorry, it's not 8. I mistake. It's 9.
Okay, 9. Okay, fine. Okay, so yeah, so this is again we need to split out this negative roots and positive roots. So this is 2. I guess this time I have wrote down the roots correctly. 2, 5, 6, and this one is -1, -3, -4. Let's say this is -7. Okay, so as someone already said, as x tends to infinity, the polynomial tends to -infinity. Okay, this is quite crucial, because once we know, then we know the direction from which the polynomial will come to 6. Okay, so since the polynomial tends to -infinity, then it will come through the negative direction. Okay, that is the below of x-axis. Okay, it will come from this direction. Mostly it will come like this. It will come towards 6. So since the multiplicity of 6 is 2, there is no other choice. It has to bounce back. Then again it will come, and then it has to go towards 5. And the multiplicity of 5 is again 2. It's even. So it has to bounce back. Then it will go towards 2, and multiplicity of 2 is odd, right? 1. So it will cross this x-axis. Again, it will come towards -1 and multiplicity of -1, 2. So it will bounce back. Then will come towards -3. Since multiplicity of -3 is odd, it will cross the x-axis, and again it will to -4, and minus multiplicity of -4 is 1. It will cross the x-axis. Then since the multiplicity of -7 is 2, it will reach -7, then it will bounce back. Okay, so since now we have the graph, from here we can compute the turning point. So this is one turning point, this is second, guess this is third, fourth, 5, 6, 7, 8, 9, 10. Okay, so yeah, so I guess the correct answer is 10, right? So I have marked in all places, right? So this is a turning point, this is another one, this is this one, this one, this one. Okay, so the answer is 10. So whether whether this explanation is clear to you, how to draw the graph, and once you draw the graph, finding the turning points is easy. Any question?
Hi, Subhas, this is Naresh. Just basically wondering if the multiplicity is 3 or say 4 or maybe 5 or 6. So
it doesn't matter. It doesn't matter. The only so if you increase the multiplicity, then it's if you draw the graph in Desmos, then probably you can see some difference. Okay, but certainly it's not going to affect the turning point. Okay, so only thing you need to check whether that number is even or odd. Okay, if it is even, then it will bounce back. If it is odd, then it will cross the x-axis. It doesn't
so
matter.
the number of the turning points will not change.
No. You will get the same thing. So only thing you need to check whether the multiplicity is even or odd. It doesn't matter whether it's 3 or it's 5 or it's 6. It doesn't matter. You need to check whether that number is even or odd. If it is even, it will cross the x-axis. It will bounce back. If it is odd, then it will cross the x-axis. Okay. Okay. Any other doubt?
I think it's fine to me.
Yeah. Okay, so basically I have completed what I have prepared. So I guess now you can ask your doubt. If you have some doubt, you can ask me.
Do we have any shortcut to do the last question?
This one. No, so there is actually no, it's not. There is no shortcut for this last question actually. So the problem is the only shortcut is if someone will ask you find the maximum number of turning points, then there is a shortcut. You compute the degree, you just subtract the degree with 1. Like then from there from there you can get the maximum number of turning points. But if you want to find out the exact turning point, then you have to draw the graph. Okay.
Thank you, sir.
Yeah, once you draw the graph, then only you can get the exact turning point. Okay, any other doubt?
Sir, I have a question. See, the thing is, I wanted to know, we are allowed calculators?
No, calculator. I guess you can't take calculator in the portal actually. So in the TCS center, you can get calculator on your screen. Like there, I guess you can get calculator. You don't have to take separate calculator for exam.
Okay. And sir, what is the duration of the exam for mathematics?
I guess 1 hour, right?
Okay. It is totally 4 hours.
Hello, sir.
Yeah. So you have so just a minute. So you have 4 subjects, right?
4 subjects, yes.
Yeah. So then I guess the duration is 1 hour. Yeah. Yes.
So it's 1 hour per subject, right?
Yes, total 4 hours.
Probably
But
if you
Just now you
have,
said the
no. No, if you have some combined subjects, like suppose maybe if you are giving the exam at the same time for mathematics and maybe for CT, then you can probably, I don't know, you have to read the guidelines. Okay, so that I'm not sure, but from the timings, it seems that for each subject you will get 1 hour. Okay, but if you have combined subject, like for maybe math and stat, if you are getting 2 hours, I don't know whether whether you can manage your time accordingly. For maybe you can spend 1 hour 15 minutes for stat, and you can finish your math in 45 minutes. That I don't know. Like whether you have to submit at exactly after submit the answer after 1 hour or maybe after 2 hours, that I don't know. You have to see the guidelines.
In terms of maths, the highest weightage chapters?
Sorry, number of question, I guess it's 10, I guess.
10. What about the weightage for the chapter?
Chapter wise, what is I don't know. Like basically, see, I'm not sure whether we are planning to disclose that weightage. See, if certainly if we'll disclose the weightage, then we'll send you an announcement. I'm not going to tell it in this session. Okay. So if we are going to disclose the weightage, then we'll certainly send you an announcement. I'll discuss with the other team members, and if they are fine on disclosing the weightage, then we'll send you an announcement. Okay.
Another question.
Subhas is there.
Yes.
Another question is that is the questions levels are at intermediate level or JEE level?
Okay, so I don't know what is JEE level, because I really don't know about the JEE level nowadays, because I gave long back JEE exam. So probably I guess it's not of the JEE level, like the time when I gave JEE exam. So certainly the level is less than JEE level.
What is your recommendation for the practice questions, sir? Which book or which any material we can refer?
No, mostly I guess, so if you solve the question of this NCERT book, right?
NCERT 12th standard, is that enough?
Yeah, not 12, I guess. Yeah, 12, sorry, 12th standard. that is, I guess, enough for the exam.
Okay, that's fine. Thank you.
Yeah.
11th is not needed.
Sorry?
Class 11th and NCERT is not required.
I guess I guess class 11 and 12, I guess, yeah. Because in 11, I guess you'll get most of the thing apart from calculus. Okay, for maybe calculus, you have to refer class 12. Okay.
So Subhas says, I would narrate this side again. I think we were talking about the maximum number of the turning points and say exact number of the turning points. What exactly is the difference between these two? Because from the graph, because turning point is a turning point.
No, so the thing is, okay, so there is a, if you go and rewatch the lecture, like in the lecture, like from the degree, actually, if the degree is 5, okay, so if the degree of a polynomial is 5, then without thinking anything, you can say that the polynomial can have at most 5 minus what 1, which is 4 turning point at most.
At most, okay.
Yeah.
Okay.
But
your point.
Yeah.
Got your point.
Yes. Okay. Okay. Any other query?
Sir, this may not be related to the exam, but in the classes, Professor Madhavan, he had said about cardinality of naturals, integers, reals, and rationals. So he was saying like cardinality of naturals and integers are the same. Cardinality of that part was confusing. How is it, sir? Like,
Okay. So the thing is, okay. So let me tell you, this is not the part of your syllabus. Okay. So still, if you want me to discuss, then I can continue. Okay. Hello?
Yes, it is. It might not be part of the syllabus. Yes, I was
Certainly
just
it's not the
confused.
part. No, it's not in the part of your syllabus, because maybe for the last 3-4 lectures. Yeah. So actually the thing is, okay, so there is a concept of cardinality, like you can say that two sets, they have same cardinality if you can find a bijection in between them. Okay. So
Yes.
so actually it is possible to find out a bijection between set of natural number to set of integer. Okay. So you can find out a bijection between set of natural number to set of integer, but it is not possible. Okay. So this is a huge thing. This
Okay. Okay.
but it is not possible to find out a bijection from the set of natural number to set of real. So this is a theorem of Cantor, like there is a Cantor diagonal process. Okay. So using that process, you can actually prove that there is no bijection from the set of natural number to set of reals. Okay. And again, one more interesting thing is, actually you can find out a bijection between the set of natural number, okay, to set up rational.
Yes.
Okay. So again, it will take maybe 1 hour, maybe 1.5 hours to discuss all these things, because as I said, whatever I said, all these things requires proof. Okay. So you need to find out a precise map. Okay. A map from set of natural number to set of integer, which is a bijection, and to say that the cardinality of n and cardinality of z are same. Okay. To say that the cardinality of n and cardinality of q are same, again you have to provide a precise bijection from n to q. See, for n, to finding a bijection from n to z is slightly easy. Okay. But finding a bijection from n to q is difficult, and to show that there is no bijection from n to r is even more difficult. Okay. So that again, this is not in your syllabus, but okay, these things are maybe like these are very interesting. I can suggest you some books, maybe you can see. So there is a book, probably maybe maybe I'll say that it's better if you see these things after your exam. Okay.
Okay, sir.
So this requires time. So maybe there is a book called Book of Proof. Okay. Richard Hammack. Okay. So from there, or maybe there is a book on calculus. Okay. So most of the thing, whatever I said, you can get it from calculus. Okay. So there is a book on real analysis. Okay. By Bartle Server. Okay. So in the first chapter, I guess first or second chapter, you can get all these things. Okay.
Thank you, sir. Thank you.
Okay. Yeah.
Sir, can you share the PDF that you explained just now? Actually, I missed first half of this session.
So yeah, certainly, I'll share the PDF. Can I share it now in the chat box? I don't know. Is it possible for me to share something in PDF in the chat box?
If it is a Google link, you can share, sir. Is it Google Documents?
So no. I guess it's a plain PDF. Okay, I'll do it maybe in the end. Let me create the PDF, and after that I have to put it in my Google Drive. Then I can send it. Okay. So okay. So any other questions?
Is graph theory and graph algorithm also in the syllabus?
Yes. I guess yes. Graph theory is in your syllabus. Yeah. So whole Maths 1, I guess, is in your syllabus.
Okay, sir.
Hello.
Yes.
Will you be sharing the recorded session?
I guess yes. Yeah.
Last time we had a session for Python, and the host name is Mayur. He said he will share. He didn't share it now.
So again, like it's not depend on the, so it's, I have to ask with the portal team. So I have if they are recording this session, then only I can share with you. If they have not recorded it, then certainly I cannot share.
It is showing meeting is recording is progress. So
okay, so then
I
definitely
joined late. I
yeah,
just joined. I didn't know the timing properly.
Okay. Then probably we'll share the session with you. Okay, don't worry. I'll
Hi, sir.
contact the portal.
And how many questions will be there in mathematics session?
Mathematics session or mathematics exam?
In exam, how many questions will be there to solve?
Can you see my screen? Hello?
Yeah.
Can you see my screen?
No.
Not yet.
Okay, then it's good. Check. Okay, just a minute. Let me verify. Okay, so there are 12 questions. Okay. Hello, am I audible?
Yeah.
Yeah,
Yes.
there are 12 questions in your exam.
Okay, then how many marks will be there total?
Marks, I guess 50 or maybe 100. Okay, so it doesn't matter. Like, so I guess
Hi, sir.
generally we prepare questions of 50 marks, and what they do, they double the mark. They make.
Okay, I have one more question.
Hmm.
Regarding this session, how many questions you solved? Because we joined just 10 minutes ago. So,
I guess 5 questions or maybe 6. Yeah.
okay. You will be sharing the remaining questions as well, right?
Just a minute. Yeah. So I'll share the PDF with you. Okay, don't worry. Just now I'll share the PDF.
That's all from my side. Thank you.
Hi,
Sir,
sir.
will we have more sessions like this?
You have 3 sessions. Okay.
Hi, sir. This is a solution to the mock test papers, which is uploaded in the diploma website. Is there any solution for that?
I guess yes.
Okay.
Yeah.
Subhashish, sir, I have to leave for the next call. Thank you so much for your time and your explanation today. It was really nice. Thank you so much.
Thank you. Okay. So any other
Sir, do we have negative marks in the exam?
there is no negative marks. Okay, so one thing is for one thing you have to be very careful. Okay, so for multiple correct question, okay, if you mark only on the correct options, okay, then you will get partial marking. Okay, so but if you mark some correct option as well as in the wrong option, okay, then you will lose all the marks. Okay, so for multiple select question, you have to be very careful. Okay, because once you click on a wrong option, then you will lose all the marks. Okay, so if you are sure, then only you mark on a option. Okay, because suppose you have marked on a correct option and as well as in a wrong option, then you will lose all the marks.
Okay, sir. And one more question from my end. So, do we have the sectional timing? Like, for suppose if the maths is started right now, and as you said, it will be 1 hour. 1 hour is completed, and if we start some statistics on another subject, then can we come back to maths to solve the problems, or
Okay, I'll suggest it's better if you ask this question. I'm not sure, but I guess if you ask this question in the exam center, then probably you'll get the answer. Okay, so you can ask it in the center. Okay, so I am not sure.
Okay,
I cannot assure you anything about this.
In Python session, Mayur was saying there is a toggle option wherein you can go back and then try with different options.
Okay, maybe.
Okay.
Sir, good evening, sir. Sir, I've recently only joined. So this mail regarding for attending the classes, it said revision session. So was there any other previous session held for qualifying this exam?
No. This is the first session. So that's why we discussed from week 1 to 4. Okay. So in one more session, we'll discuss calculus. Okay. and
Okay,
another
sir.
session we'll discuss logarithm function and graph theory.
Okay, sir. If I have missed any classes, is there any way to see the recorded session?
So this is, as I said, this is the first class, right? This is the first study.
No, sir. Other than your subjects, like for example, with Python, which was held yesterday, I suppose on 15th, guess, I couldn't attend the meeting. So is there any way?
I'm not sure. Like I don't know about Python. It's better if you send a mail to the support team. They can help you out. Okay.
Thanks, sir.
But certainly I'll try to share this session. This recorded session with you. I'll inform them to share this recorded session with you. But
Okay,
I'm not sure about Python. For Python, I'll suggest you to send a mail to this portal team. Okay.
Okay, sir.
Okay, so I guess now I'm saying, okay, so now I guess you can get the link. Okay, maybe I have said the wrong. Okay, sorry. I need to... Just a minute. Yeah. So, okay, so now you can see the, I have shared the slide with all of you. Okay, so you can, I have shared the link. You can check. Okay.
Sir, is there any cutoff mark like for the total exam, or will it be changed once the results we got? Like, if the maximum participants have scored the highest mark, will the cutoff be changed, or will it remain the same, the 50%?
No, I don't think they will change it. So most likely the cutoff will be the same. Okay. Most likely, again, I cannot assure you anything, but most likely it will be the same.
Okay, sir. Thank you.
Okay, so any other doubt, or shall I stop the session?
So when we will have the next session?
Maybe next Sunday. Okay. Or
Sir,
maybe
this exam will be computer based?
Maybe next Sunday, or maybe before that. Certainly you will get a mail. Don't worry. Like for the next session you will get a mail. Yes. This is so you will go. You'll give the exam in TCS center. So everything will be on computer based. Okay.
Oh, thank you.
Okay, thank you. Yeah. Okay, so then okay, again, I have shared the slide in the chat box, so you can, if you want, you can take copy paste the link. Okay. Okay, so okay, thank you.
Thank you, sir.
I'll stop the session. Yeah.
Thank you, sir.
Thank you.
Thank you, sir.